Hi everyone, my name is Arnau Blanco, and in today's video I'm gonna show you how to compile and debug C code using Visual Studio Code on Windows, macOS and Linux. Specifically, we're gonna take a look at how to install the compiler and the debugger and how to configure VS Code to use them. Since I'm covering all three major operating systems, feel free to use the chapters below to jump straight to your section. So let's get started. Before we start, let me give you a bit of context so you understand what we're doing today. The C programming language was invented in the early 1970s by a man named Dennis Ritchie. At the time, he and his team were building a brand new operating system called Unix. Back then, you had to write operating systems entirely in assembly language, meaning that you had to specify exactly what you store each variable in memory and how to perform every single operation. Even worse, those instructions changed for every type of computer chip. So Dennis created C so they could write Unix just once and easily port it to any computer architecture. This was a massive breakthrough since Unix shaped the modern tech world. For example, in the 1990s, it inspired the creation of Linux, which today powers everything from cloud servers to the Android operating system on your phone. Also, in the 2000s, Apple used Linux to build Darwin, the foundational operating system that powers macOS, iOS, watchOS, and everything else in their ecosystem today. The idea is very simple. First, you write a program in a high-level language like C, and then you use a compiler to translate that program into binary instructions that your CPU can understand, wrapped inside an executable file that your operating system can run. The way it works is like an assembly line. You write your code in C, which translates that code into assembly language for your specific CPU architecture. That assembly is then converted into raw binary instructions, and as a last step, those binary pieces are glued together into a finished executable file that you can actually run. So the next question now is, where is this very famous compiler? The most famous one is GCC, which is part of the GNU compiler collection created by the GNU project in the 1980s. If you're a Windows or Linux user, you'll most likely be using this one. In the case of macOS, Apple has their own default compiler called Clang, which is heavily optimized to run on their Apple Silicon chips. It was originally started by Chris Ladnert as part of an open source project called LLVM. And in the 2000s, Apple hired him and funded his team to build Clang for Apple systems. To write your code, the most popular free code editor in the world is Visual Studio Code, which was developed by Microsoft. Now imagine that you're writing your code and suddenly you want to know the exact value of a variable at a specific line. How do you do that? That's the exact job of the debugger. If you're on Windows or Linux, you'll use GDB. Otherwise, if you use macOS, you'll use LLDB, which comes installed by default, just like Clang. So let's jump into the screen and get everything installed. I'll explain the installation process in detail, but you can find the instructions in the description below. Let's start with Windows. The first thing you need to do is to go to the official webpage of MSYS and download their installer for your PC architecture. Now, open the installer and go through the installation process. Open MSYS. Copy-paste the following command and wait until the installation is finished. To verify the installation was successful, go to the following path and make sure that GCC and GDB executables are there. As a last step, go to Environment Variables and create a new environment variable with a path where GCC and GDB are, as you see on screen. To double check that GCC and GDB are correctly installed, open a terminal and type gcc-version and gdb-version. To download VS Code, simply go to their official webpage and download the Windows version. Make sure that you install the C++ extension and you're good to go. Now let's carry on with Linux. It may happen that GCC and GDB are already installed, To verify that, open a terminal and type gcc-version and gdb-version. If you get an error, it means that they're not installed, and you have to do so with the following command: sudo apt install gcc gdb. To install VS Code, you can use the following command: sudo snap install code --classic. Once it has been properly installed, make sure that you have installed the C++ extension in VS Code. Finally, let's get to the installation of macOS. First, verify that GCC or Clang and LLDB are not already installed by typing gcc-version or Clang-version, LLDB-version. If you get an error, you can install them with xcode-select --install. Now, to install VS Code, simply go to their official webpage and download the macOS version. Make sure that once it's installed, you can also install the C++ extension. Imagine that you've written a snippet of C code and you're ready to run it. You have two options for how to do this. The first option, which is a bit tedious, is to manually open your terminal every single time, type GCC or Clang on macOS, specify your C file, type -o, and then type the name of the executable you want to create. The second and much better option is to integrate your compiler and debugger directly into VS Code. This turns that entire multi-step terminal process into a single click of a button, but that needs to be properly configured. To do so, you need to open your project and select the folder where your C code is. To configure your compiler, press Ctrl-Shift-P or Command-Shift-P if you're using macOS, type task, configure default build task, and then select your compiler from the list. That will generate a hidden folder called .vscode inside your project folder that will contain tasks.json, which is the file that will allow you to integrate the compiler into VS Code. Now, every time you press the play button, it will execute that task and it will compile your code. You don't need to know exactly how the configuration works, but here are the most important fields in the config file. Label, which specifies the name of the task we're defining. Command, which indicates the path of the compiler, like GCC or Clang. Args, which are the arguments after GCC or Clang. And notice that we add -g, which allow us to run the debugger later. And finally, group, where we specify that this is a build task and that it's going to be run by default. We need to do the exact same thing for our debugger so we can pause our code and inspect our variables. To do this, click on Run and Debug icon on the left sidebar, create a launch.json file and select C++ GDB LLDB from the drop-down. This will create a second file in our .vscode folder called launch.json, which will allow you to integrate the debugger into VS Code. You need to specify the path of your debugger in mi-debug path and the task you want to associate this debugging with. In our case, the task we defined earlier. Finally, you also need to indicate what is the executable the debugger will work on. Now we are ready to debug by clicking on the launch configuration we just defined. If you're on macOS, I strongly recommend to install the code LLDB extension, since VS Code has limitations and doesn't allow you to run the C code on an external terminal. That is a problem since the internal terminal is a read-only that doesn't allow you to type in any input. Make sure that you specify that the terminal is external. Now imagine that you have a project that contains 3 separate C files that are all connected and you want to debug it. To do that, we need to make sure that our compiler includes every single one of those files. Up until now, our task.json file used a variable called file, which tells VS Code to only compile the single file currently open on your screen. Now we have to manually list out every single file path in the arguments array, like workspace folder /main_c, workspace folder /util_c, and so on. That will glue them together into our executable. And that's it for today's video. Now you have VS Code configured and ready to start programming. Bye bye!